solutions to some real world problems that you have been facing, and in less than 24 hours that too, right? So this is going to be quite something. Very eager, looking forward to all your creativity and in problem solving and the solutions that you bring together. With that, I'm going to give it up to Shooting Stars for a quick presentation. And we have our amazing keynote speaker online here with us today, Tanmay Bakshi.
Thank you.
Woohoo! Yep. Okay, so we just have a very few slides now. We'll go through and then hand it over to Tanmay. Okay, go ahead, Abhi.
Yeah. So can you move to the next slide? So I'll quickly cover through the agenda. I think it's a very small agenda, but a few slides. We will talk about Shooting Stars Foundation first and some of the pre-events that we have gone through together in this journey. We'll talk about the mentors, the SMEs, the volunteers from IBM and SSF. Then we'll go for the keynote from Tanmay. We also have a fireside chat. IBM-Z ambassadors will be joining us there. And at the end, we'll be covering a few of the Datathon specifics, right? So it includes the Datathon guide, the Discord channels, and yes. So we can move to the next slide. I'll be a little quick over here because I know we are, all of us are waiting for Tanmay's keynote. So, so just a little about Shooting Stars Foundation. So, so we are a nonprofit based out of US. What we are currently trying to do is empowering individuals and communities through education. We usually do it in three main ways. One is to educate through STEM programs. The hackathon is a STEM program. Then we empower students, underprivileged students through scholarships. Currently, we are supporting more than 450 students across 8 different countries, helping them with their education. And last but not the least is enabling students through mentorship, through guidance, through career panels and things like that. Yes, let's move to the next slide. So it took us a few events to reach here. We have been working on this internally with IBM for about 4 months now. A few events that you must have joined. First of them was the speed teaming event. So about 130 students from 10 countries joined. We created 15 teams in under an hour, and all these students belong to different parts of the world, never met each other, and it's a big thing that in the 1 hour they came onto cameras, then they met and they introduced and they formed teams. Next, right? So on September 15th, we had the IBM-Z Day. So it was a fantastic event. We had excellent speakers. Sudarshana Komal joined me, and I think we talked about IBM-Z, the fundamentals of enterprise computing. Over 150 students joined us. We had $500 in prizes, and it was an excellent event. Next slide. Yes, just yesterday, Alex and Joe were here with us. They presented, they took us through the IBM-Z platform. They gave us a demo of the platform. They shared the best practices for the students to keep in mind while submitting their ideas. Again, thank you, Joe and Alex. It was very helpful. Yes. One final slide before I pass it to Sok. I mean, so from SSF, we really want to thank our IBM mentors, the experts, the volunteers. Thanks a lot, Sudarshana. You've been leading it. Alex, Tejaswini, Joe, Nasser, Jean, Christopher. Thank you so much for supporting us. Yeah.
Okay, so, at this point, yeah, thank you, Abhi. So I hope you guys are equally excited as us. So we just wanted to, give credit to this, the efforts of everyone who actually are working on this Datathon event for all of you. So here is actually, a list of our warriors that we can call who are working tirelessly, right? So here is Abhi, yeah, the one that just walked us through the agenda. We have Akanksha, Kamal, Lata, Ansh, Ishi, Kevin, Abhishek, Kevin, Yati, and Sudan. And we will be with you from this point on until the very end of this Datathon event. So we just want to say that you have our full support on this Datathon event. All right. And as for this Datathon event, do you know, guys, that we have 1,400 registered participants in this Datathon event. So thank you, everyone, for all of you who made this huge Datathon event very, very successful. Thank you. And out of these 1,400 participants, we have formed 80 teams already. Imagine, you know, the long hours that our judges will be spending on judging your work, guys. So, and not only that, since this event is really a global event, wherein 38 countries have participated. So we have a lot more, majority of that coming from India. We also have coming from Kenya, Africa, even Philippines, right? So thank you everyone for making this happen. And also, while we have 1,400 participants, as you can see, we have 10 IBM volunteers. So thank you for these heroes. And we also have 20 volunteers from Shooting Stars Foundation. So these are, you know, the village who are working behind this event, just for all of you, and making this happen for you to have that experience of, I know, a very, very great Datathon event. So, all right. So for this one, just sharing with you guys some Saturday morning participant blues, where our participants have shared their feedback, right? So some have found this, you know, and appreciated the efforts of all the volunteers and also the subject matter experts coming from IBM. So thank you, everyone. And now, I have 2 questions before I hand it over to our keynote.
Oops. Sak, did you go through the previous slide? Sorry.
There you go.
Okay. Yeah. So yeah, just wanted to, you know, again, Sak, you kind of ran through this, which is okay. I just wanted to see the excitement. You know, these are actual, you know, reflections by our students, and there you can see selfies as of last night, as of today morning, right? Our students and participants are excited. You know, see the amount of teamwork that has already gone, and you could see from their reflections the amount of teamwork that has already gone in, and the kind of different experience, right? I mean, you kind of have these events like, you know, within one community and all that. Now you're talking worldwide, thanks to the pandemic, we are holding it online, and you know what kind of thing. So yeah, we are just very, very happy with the collaboration and the international perspectives that has brought this together. Thanks, Sak. Go ahead, please. Sorry, I just want to highlight.
Yes, Lata. Thank you so much, and thank you for these selfies, guys. All right. So before I hand it over to our keynote speaker, I have 2 questions for all of you, and please use the chat box. Okay, we would really appreciate your answers to this question. Okay, my first question is, what were you doing when you were 5 years old? What are the things that you know? What are the things that you have learned when you are 5 years old, guys? Can you have that in the chat box, please? Everyone? Some actually said nothing at 5 years old. Okay, how about the others? Maybe talk, right?
Designing future gadgets.
Designing future gadgets, watching Pokemon. No, learn how to color and all that. Okay, all right. And my second question, thank you so much. Thank you guys. These are great. Tom and Jerry, ABCD, alphabets and all that. Great. Okay, so remember that question at 5 years old, okay? Now, my second question, maybe for those, actually for all of you. What age have you learned coding? For those who know how to code, okay? At what age have you learned how to code? 13, 34 to 35, 18, 16, 20, and all that. Great answers, you guys. Thank you so much. Okay, so the question being is that I really find it very, very interesting for our keynote speaker. Did you know, can you guess, guys? Can you guess? Give me a wild guess. How old is that did Tanmay started coding? Just a wild guess. Okay, I think Hashim knows Tanmay very well. Okay, that's the first answer I got in the chat box. Okay, can you believe it, guys? Can you believe it that our keynote speaker started coding at 5 years old when we are studying alphabets, learning how to color, watching Pokemon and whatnot, right? So that's how amazing this guy is. He started coding at 5 years old. And first iOS app at 9 years old. Can you believe that? And at 12 years old, he was the youngest IBM watching programmer in the world. All right. So that's just, 5 to 12 years old of his life, guys. But now I'm going to go to the meat of who Tanmay Bakshi is. So he is, a famous TED and keynote speaker, right? So he is also a Google developer, IBM advisory software engineer, and guess what? He's also a huge fan of SpongeBob SquarePants. So I guess that's the secret of Tanmay in terms of how he learned how to code and all that. But okay, without further ado on that, I just wanted to inspire you guys that while our keynote speaker is actually really, really young, started really, really young in this space of technology, playing with data. So without further ado, let's welcome on stage Tanmay Bakshi. Let's give him a round of applause, guys. Thank you.
Thank you. Thank you very much. I'm very excited to get to be here today and get to speak with all of you. I mean, again, I really wish this sort of thing could be done in person, but I'm sure that soon, hopefully, with more COVID stuff dying down, hopefully more people getting vaccinated, we'll be able to meet in person too. But no, I'm very glad to get to meet you all virtually today. I'd love to go ahead and share my screen. There's a couple thoughts I want to share, but I want to keep this super interactive. So any questions that you might have, feel free to put those in the chat. I'll definitely get to those. And yeah, I just really want to share my thoughts on AI and machine learning, something that I've been really passionate about for a very long time, and show you some of the interesting projects I've been working on, as well as some of the technologies going behind them. And I'd love to go ahead and start. Let's see, I can share my screen. We're actually going to get to take a look at some really fun examples of artificial intelligence today, including some music that's probably going to be more unique than any other music you've heard so far. And I think it's going to be really fun. So let's get started. Now, just really quickly, I do want to start off by telling you all a little bit more about, who I am, and, why I'm here today. I mean, as we mentioned, my name, I'm Tanmay Bakshi, and really, I've always been passionate about two things, right? I've been really passionate about building technology and innovating and sort of applying it in domains where I think it can really have an impact and augment human lives, but also about enabling more people to use that technology, right? Making it so that more people can take that technology, use it to solve their problems and problems that they see in their communities, as well as even understand on a higher level the sort of impact that technology has on their lives, right? Those have always been my two main goals. And to sort of work towards these goals, I've had resources like, for example, my YouTube channel called Tanmay Teaches, where I like to share my knowledge on all sorts of topics from, computing and programming to math, science, different algorithms, machine learning, as well as my 4 technology books that help you, for example, learn how to code from scratch in languages like Swift and Julia, including Tanmay Teaches Go, my book to help you learn the Go programming language for backend development, sort of next generation infrastructure. Now, throughout all of this, one of the technologies that, as I mentioned, I've always been really, fascinated by, and that I've always, tried to implement in a lot of different applications, is artificial intelligence technology. Of course, it's, something that everybody seems to be talking about. But the thing is that I've always been kind of dissatisfied with the way that we talk about artificial intelligence, right? I do believe that it is fundamentally one of the most misunderstood technologies in the world, right? Even down to the nomenclature. I think we shouldn't be calling it artificial intelligence to begin with, to be totally honest. Really, I think a more valid name for a lot of the different artificial intelligence techniques we see today is really machine learning, right? That's what's going on in the back end. And I'll get a little bit deeper into that in just a second. But to give you a little bit more context, the way that I sort of got into the world of machine learning and AI to begin with was, you see, a couple of years ago, back when I was 11 years old, I had actually stumbled upon a documentary on IBM Watson and how it not only played, but also won the Jeopardy game show against the two best competitors on the game show. Now, I think it can be hard to truly appreciate how incredible that feat of engineering was, right? When I saw that, I was just absolutely fascinated, right? I immediately wanted to know how it worked, what I could do with it, and what the sort of potential is. And the reason that this is so impressive is because if you think about Jeopardy, it's one of the most complex game shows out there, right? Even humans have a hard time comprehending the clues that you get from Jeopardy, from the Jeopardy game show. But here we have Watson, a computer system able to not only process and understand these clues, but also provide responses in real time, right? Faster than humans. And this sort of made it so that I went from thinking of computers as these super rigid and inflexible, bots that sort of follow all the rules and logic that we give them, to now seeing how they can be flexible, right? That's what really fascinated me about machine learning, or what we call artificial intelligence technology. And I'd say that a lot of people seem to agree with me that this is a very fascinating technology, and not just fascinating, but disruptive, right? So if you take a look at a study by IDC, 72% of companies, all the way from startups to enterprises, actually vote machine learning as the most disruptive technology out there, right? But I think it's important to try and understand why machine learning is so disruptive, right? And there's a quote that I absolutely love that really describes why machine learning is so important. It's because of the effect it can have on existing processes and the way people will work. Okay. Now, I'm not going to tell you who said this just yet. All right. I'm going to keep that a surprise for the end. We'll get back to this. But just for now, remember this quote, and remember that it really is a good representation of why artificial intelligence and machine learning are so important. All right. Now, sort of to dig a little bit deeper into what this means exactly, because it's kind of cryptic, I think it's important to take a step back and take a look at sort of the fundamental technology layer, right? What is technology, right? Technology is its own industry, obviously, but technology as an industry also powers every other industry, right? It is infrastructure. And that is important. Infrastructure is really important. It might sound boring, but it actually is incredibly exciting. I mean, think about all these different domains, or think about healthcare and how we're using technology to have, like, for example, MRI machines to help us diagnose and treat diseases that we never could have dealt with before. How in education, we're using technology for like online education platforms and smart boards in classrooms. In agriculture, we have larger scale agriculture, enabling us to provide all the food we need to for all the people in the world, right? This is all using technology. In entertainment, we've been able to have these brand new ways of like recording TV shows and movies. Right now, we don't even need green screens. We can actually have game engines render graphics in real time, and we can record them physically, right? Think about finance and how people can trade with each other internationally instantly thanks to modern technology, right? And if you take a look at all these different use cases where, of course, we are using technology as infrastructure in what you might think are completely unrelated domains, if you try and apply these sort of next generation technologies like the ones in the survey from IDC, you notice that there's some gaps, right? So for example, in agriculture, maybe if you have like a smart agriculture use case, maybe the cloud isn't as important because you want to run more compute on the edge. And you want to be running things locally so you don't have latency going to the cloud. Maybe cloud doesn't work. Or maybe in entertainment, blockchain isn't as important, right? Because, what are you going to do with a blockchain in an environment where you're recording a movie, right? Or maybe in the classroom, IoT isn't as important of a technology to implement, right? There are these limitations in all these different use cases where these technologies don't fit, but the technology that does fit everywhere is machine learning, right? That's the technology that works across all these different domains, right? In healthcare, we can use it to analyze patient data. In education, we can analyze student answers and determine their accuracy. In agriculture, we can predict the optimal time to harvest crops and water them. We can do more intelligent computer graphics like Disney does with machine learning for their movies. We can try and understand the sentiment and the trends behind different stocks and different assets. And the reason that machine learning can be applied everywhere is fundamentally because if you strip away all the fancy math and all the UX on top of machine learning, you start to realize that fundamentally it's all just data analysis, right? It's all just about taking very large data sets and trying to find patterns in them and trying to gain some kind of insight. And what's really nice about modern machine learning, what's different from the machine learning we've had in the past, and the reason that we have all the hype around it now, is because modern machine learning, deep learning, can understand unstructured forms of data, right? Things like natural language, visual data, auditory data. This is something that previous machine learning algorithms couldn't do, but that we can today. Right, and I've been able to use the power of this data analysis technology in a wide variety of different projects spanning across many different domains. And there are two that I find really interesting personally that I think you'd find fun as well. And I want to start off by sharing one of them, and I call it Hard ID. Now, Hard ID, as the name suggests, is a project that enables me to use deep neural networks that I've built to identify you based on the way that your heart beats. So kind of like how you can use Face ID for facial recognition on iOS devices, you had Touch ID in the past, so on and so forth. Heart ID can recognize you based off of the electrical activity of your heart. That's your electrocardiogram. Now, of course, the way it works is I start off by training my own neural networks to understand how to extract unique patterns from electrocardiogram data. And then what I can do is take new electrocardiogram data that the neural network's never seen before and extract unique features from it and store those features in a database. Then, when I'm given even more new electrocardiogram data, I can try and match it against the features that I've previously extracted and see if they match. That's the idea behind Heart ID. And it works surprisingly incredibly well. So take, for example, me and my sister, right? What I went ahead and did was fed in electrocardiogram data from the two of us and plotted out sort of the internal representation that my neural network generated for the electrocardiogram data from me and my sister. And as you can tell, they look very different. And that is precisely the key, right? If those two internal representations look different, there's a greater probability that the two people they came from are different people, right? It's not the same person that you captured electrocardiogram from. Now, I've had the opportunity to do some really fun demos with Heart ID, but recently I got the opportunity to do what I think is easily the most fun one yet. So I have two friends, their names are Raquel and Simone. And recently I found out that they have the incredibly rare ability to trick Apple's Face ID. Right, so kind of like how, you know, on your new iPhones you have the iPhone 30, you have the Face ID feature, so you can use the true depth camera system to unlock your phone with your face. They can actually trick Face ID, right? Even though they don't look alike to us as humans, somehow to the true depth camera system and to the algorithms that Apple is running on their device, they look similar enough to unlock each other's phones, right? This is incredibly rare. This is like less than 1 in a million of a chance that this actually happens. As a matter of fact, take a look at this demo really quickly. Simone, of course, can unlock her phone with Face ID. That's normal. She can give it over to Raquel. She can also unlock the same phone. And if you take a look at settings, go into Face ID, there is no alternate appearance setup, right? This is just a single face that's being used to unlock or that's being trained on for both of them to be able to unlock the phone, right? So they were able to trick Face ID, but Heart ID works. Watch this. So if I capture a couple of seconds of data from Raquel using these electrodes that I've put on her, the neural network can correctly identify that she is Raquel. Similarly, if I were to go ahead and capture a couple seconds of data from Simone using the same electrodes, my neural network can indeed identify that this is Simone. And so that's the idea of Heart ID in action. And so hopefully you enjoyed that demo. And once again, this is what I can do with the power of deep neural network technology and modern machine learning, right? This is something you could never do in the past, even if it was theoretically possible. right? And so I love applying machine learning in these sorts of fields. But really, what I'm super, super interested in is applying machine learning with language, right? Language has always been an area of interest for me. And the reason for that is because language is very fundamentally human, right? Language is one of those things that sets us apart from every other animal on the planet, right? It's the fact that we can communicate with such high fidelity is incredible. And you might think that the human mind sort of shapes language, and we're the ones that, of course, create and structure language, but really it goes the other way around as well, right? Language in and of itself can also help shape the human brain and the way that we think and act and do things. And one of my favorite examples is, well, let's actually play a game and take a look at it, all right? So here are 3 shades of blue, all right? 2 of them are the same, 1 of them is different. Hopefully you can pretty easily tell which one's different in this case. So I'm gonna have to ask you to guess, all right, as to which one's different. I think I can actually pull up the chat if I get to see my cursor. Unfortunately, I can't see the chat while I have slides up, but if you were to take a look at these 3 shades, right, more than likely, you can tell that the shade of blue that's different is B, all right? B is the one that's different in this case. Well, let's take a look at another example. These are gonna get a little bit harder, all right? What about now? These are a little bit closer, but hopefully, if you guess, you can tell that the shade that's different is C. All right, let's do 2 more. What about now? A little bit closer again. You got A, B, and C. Which one's different? Let's see, it is B. All right, now we're gonna do one last over here. This one's the closest. Of course, we could keep going and get harder and harder. I don't wanna get too hard right now. But if you take a look at this, you can likely tell that the shade of blue that is different is A. All right, why did I just do that? Well, I did that because, did you know, it is statistically more likely that you would be able to tell the difference between different shades of blue the closer and closer they get if the first language you speak is Russian instead of a language like English. Right? Why is that? It's because in Russian, there are just more words for the color blue. And so fundamentally, your brain is structured in a way to be better at telling between blues. So the closer these shades of blue get, if you spoke Russian as your first language, statistically you are more likely to be able to tell the difference between the shades. Right? So that's what I mean by that relationship goes both ways. The brain structures language, language structures the brain. And now we, as being the intelligent humans we are, we've sort of gone back and tried to structure language and apply formal rules to it so that we can standardize the way that we speak. And this leads to further complexity sometimes, right? You can have sentences like this that don't really mean anything, right? Colorless green ideas sleep furiously. That doesn't mean anything. It's almost nonsensical. But grammatically, there's nothing wrong with it. You can parse it into a syntax tree and everything is totally fine. Despite all of this complexity though, with deep learning technology and machine learning technology, we actually have the capability of being able to comprehend this data, right? And being able to process it with the machines and the technology that we use, which is incredible. But the fact that we can do such complex things leads to a slew of misconceptions about artificial intelligence and machine learning and what they're meant to do. For example, a lot of people are under the impression that AI is about simulating human intelligence, and I kind of don't blame you because it's literally called artificial intelligence. But that's, again, not what it's about, right? Machine learning isn't about simulating human intelligence. It's not about replacing human jobs. And it's also definitely not about surpassing human intelligence. It's really about enabling us to have new capabilities by giving technology new capabilities so it can help us do more things. As a matter of fact, there is another project that I've worked on precisely because I wanted to create an application of value and disprove these sorts of misconceptions at the same time. You see, last year, I stumbled upon a news article talking about how artificial intelligence is going to replace songwriters and how a study on AI lyrics suggests that it's possible. And I thought immediately to myself, no, that's not how this works, right? AI, machine learning, it's not going to replace songwriters. And, there's all these other news articles about replacing developers and journalists and insert random field here, right? Replacing everybody. But that's not what artificial intelligence is about. And it's really annoyed me sort of seeing how people have these misconceptions. And what I wanted to do is dispel these misconceptions. And of course, as I mentioned, create an application of value. You see, the thing about using artificial intelligence to generate lyrics is that we're working with art, and art is creative. So you can't just give this all to a computer to do. You fundamentally need a human in a creative process, partially because, of course, some of the value of art is the fact that human emotion went behind it, but also because neural networks don't invent anything new ever. They only restructure things that they've already seen before, right? Like take, for example, these lyrics on screen right now, right? In order to generate, for example, another verse given this verse in the same song, you need to understand a whole plethora of things about human society that you don't realize you already know because you're a human, right? Even just this second line, to understand it, you need to understand that humans are animals that need sleep, and that not getting sleep is a bad thing, and that Tylenol is medicine that's supposed to help you sleep, and that this isn't like, and then being able to understand what the metaphor is for why you can't sleep. It's incredibly complex, right? And then even apart from meaning, just the way that it's structured is complex. Right? You don't realize this, but when you start going through the data science process, you realize that not only are there words on screen, but there's also, for example, new line separators between the lines. But those new line separators mean different things. Like these first two lines are like the same sentence, but they're split into two lines because there has to be a break in actually singing the two lines. But these two lines aren't the same sentence. Right? They're fundamentally different sentences, and that's why there's a break. There is a whole sort of depth of understanding that goes behind generating and even understanding music lyrics. And then there's the fact that you don't want to take things literally, right? Like if you were to conventionally analyze this third sentence here, this third line, maybe it doesn't make sense to see things with your hands, but in art, that's totally valid. As a matter of fact, what if I told you that this verse on screen right now was actually generated by the machine learning system that I built, AutoLyricist. The idea of which is to eliminate writer's block for songwriters by giving them this sort of machine learning based capability to automatically get inspiration from computers. It's pretty fun technology. And I'm very glad to say that I got to work with some incredibly talented artists to demonstrate the power of AutoLyricist in action. So now we do have a couple minutes. I'd love to go ahead and show you all a demonstration of AutoLyricist by actually showing you the music that we've been able to record and write using the power of AutoLyricist. One of the artists that I've worked with, her name is Claudia Heuser, incredibly talented country songwriter and singer down from the US. And she worked on a song called A Summertime Song on her debut album now, with lyrics inspired by and partially written by AutoLyricist. And I'd love to go ahead and give you all a listen to A Summertime Song. Hopefully you'll be able to hear this. If you can't, let me know in the chat and I'll fix it. But here we go, Summertime Song.
It's never my intention to put the fire out, and there's really no saving this time around. Replay it over all our favorite lines. It was never my intention to unwind. Loving you is like a summertime song. It goes a blazing past, daydreaming a feeling I can't get back. Oh, a summertime song. It's never my intention to waste your time. We jumped in the deep end and I lost what I was hoping to find. Replayed over all our favorite lines. It was never my intention to say goodbye. Loving you is like a summertime song. It goes a blazing past. Daydreaming a feeling I can't get back. Oh, a summertime song. Chasing stars to the past. Daydreaming a feeling I can't get back. Oh, that summertime song. Summertime song. Oh, summertime song.
Don't want to be muted. But that was the first song using auto lyricist written lyrics. I mean, I personally have, two new favorite songs. There is one more that I want to show you. But first though, I do want to get a little bit of an idea of what Claudia's thoughts were actually using the auto lyricist system. Because, taking a look at that, the final result is definitely interesting, but I want to know what it was like for the artist. Again, the idea is to augment the artist. I mean, at first, as you can imagine, she was a little bit apprehensive, but I'll let Claudia talk about her experiences with auto lyricist.
When I was first approached about this, I immediately thought, no way. When we're writing songs, I really try so hard to pull from my own experiences of people in the room, and just try to be as honest as possible. So thinking about a computer coming up with these ideas for me, I wasn't really having it, but I'm always up for trying something new. And what I realized was it was almost like working with an open-minded co-writer who just brought all these ideas to the table. And yeah, you could sift through the ones that were crazy and not going to work for you, but it kind of allowed us to think a little differently and took one of these songs that we had started in a completely different direction. So we were able to come up and find the line, "Loving You is like a summertime song," and now we have a brand new song that I just love. Hope you enjoy it.
It's really inspiring to see that journey from, seeing Claudia initially apprehensive about using machine learning because, again, you want that human connection, those human experiences to come through, but then being able to see how using that machine learning tool is sort of augmenting her and providing her this ability to find new ways to get across her message. Once again, just truly is inspiring. There's one more example I'd love to show you before we move on and before we get to interact, and that is another song that I was able to record and write with the help of Elena Coates and James Hebert. Elena Coates is a talented pop singer-songwriter from, once again, from the US, and James Hebert helped produce the music. Easily one of the most talented producers I know. And so I'd love to give you all a listen to another song, once again with auto-lyricist written lyrics, called Take You There. Let's take a listen.
You think you know what it's like to lose and find again, to love and hurt and feel alive. That you don't know how it feels to be on your own. That you don't know how it feels to be alone. The feeling you get just fades away. The darkness will surround you. Somehow it always brings you back to life, and I can feel it in my heart. Hate that I'm missing you. I know it's hard. All I gotta say, it's time for me to say. Time for me to say that you don't know how it feels to be alone. I'm gonna show you, yeah, I'm gonna take you there, take you there. Yeah, I'm gonna take you there, take you there. Dreams last so long, so why do they fade so fast? You can't stay too long. The beat always fades away, fades away, fades away. The feeling you get just fades away. The darkness will surround you. Somehow it always brings you back to life, and I can feel it in my heart. Hate that I'm missing you. I know it's hard. All I gotta say, it's time for me to say.
Now, really quickly, just to make sure that we do have time to get to questions as well, I'm going to go ahead and put the links to both of these in the Discord chat. I'm part of the server, so again, any other questions that you have that we're not able to get to today, feel free to ask me there. But I'll be putting the links to both of these songs in Discord so you can take a look at them and take a listen. And of course, there's going to be a lot more soon that you can do with auto lyricist yourself as well. Now, one more thing that I do want to talk about,
I like to
behind this sort of technology, is that, once again, the reason that I worked on this was because there's been these misconceptions around artificial intelligence replacing people in, once again, all kinds of domains, right? And I feel like some great examples of this would be, for example, OpenAI's GPT-3. There was all this hype when GPT-3 was released about how it's a neural network that can generate text that is, at human level, and that it's going to replace people that need to write content in natural language, like journalists and developers. But really, that hype isn't true from a technical perspective. But despite the fact that that hype isn't true, that doesn't mean that the technology isn't valuable. It can still do some absolutely incredible things. Like, for example, going back to this quote that I was talking about towards the beginning of today's session. What if I told you that this explanation for why machine learning is so important was actually written by GPT-3? Right? I got access to the API and I asked it, why is machine learning such an important and disruptive technology? And this is one of the explanations it came up with. Right? Now, this isn't plagiarized from anywhere on the internet, but it's also not an entirely new and original thought, because that would require creativity, and GPT-3 doesn't have creativity. It's a neural network, right? So what I'm trying to get at here is that machine learning can be used to help people, but it's not here to replace them, right? That's the idea. Now, one more thing that I do want to talk about before I answer your questions is platforms. right? Platforms are really important to think about. And it's something that I feel like we don't pay enough attention to. But what do I mean by platforms? What I mean by platforms is what it is you're building your application or your technology on, right? For example, a little while ago, I was working on an application to sort of re-implement Shazam, the music discovery application, from scratch. And I was actually, sort of working on some educational content to sort of, tell people how they can build their own versions of this. And so I worked with my friend Simone and sort of asked her to re-implement a lot of my logic by herself from scratch to see what her experience is like implementing it. And to implement this application, we used IBM DB2 in the backend. And at first, when you're dealing with a technology like, for example, IBM DB2, that is, at this enterprise scale, something that is deployed in real world applications, it can be a little bit intimidating at first. But there's two things to realize. First of all, it's really not as hard as you might initially think it is. Right, it's actually quite easy to use, and you'll be seeing more about that soon when I release this content. But also, there's a sort of disconnect between students and what they learn, and where they end up deploying and using technology in the real world, in enterprises and in companies and in startups. And when you don't have a good technical foundation, it limits the amount of things you can do on top of it. Right? With a greater, stronger technical foundation, you have more of an opportunity to innovate on top of it, right? Like, for example, for the longest time now, there's, in the consumer world at least, been this sort of, bias towards using x86 processors for pretty much everything, right? So Intel and AMD chips. Now we're starting to see that sort of disrupted. Apple, for example, is switching to the ARM architecture with their new M1 chips. I'm quite literally doing this presentation off of an ARM chip, which as of before November of 2020 would have been, unthinkable. You'd be like, how are you doing something this complex on an ARM chip? But, we're starting to see these trends break. And in the enterprise world, there's even more evident. Right? x86 isn't the only option in terms of your platform and what you can build on top of. For example, Autolyricist was trained on IBM Power Systems using lots of NVIDIA GPUs on Nimbix. And Autolyricist's inference, including all the lyrics that were written for Take You There and for Summertime Song, were actually written, and the inference for the neural networks was run on IBM Z machines, right? Which is what you're working on, or working with rather, in the Datathon. Now, what's incredible is that this project spans across 4 different compute architectures for all kinds of things, right? And so what I'm trying to get at is that when you're building your applications, it's important to think about the stack of technology that you're building your application on to give you the right tooling and the right infrastructure to make it so that you can innovate on top of that and actually solve problems. Right? In this specific case, Autolyricist, after training, didn't require that immense GPU power, but it was nice to be able to scale with the IBM Z CPUs that I was given, right? And for certain other use cases where, for example, security or uptime is incredibly important, being able to run on IBM Z machines is, absolutely huge. It changes how you're able to provide offerings to your clients. And so with that, I do want to say that as you're using, this technical infrastructure, and as you're going about the Datathon and continuing to innovate with technology, I think it's really important to keep in mind that fundamentally what all of us developers are doing is we're using technology to solve people's problems. Right? That is fundamentally what development is all about. It's about seeing problems and applying our problem-solving skills to be able to use technology to make it so that we can help people. And so with that, I'd love to go ahead and now answer any questions you may have in the Zoom chat. I do know we have a couple already, and I'd love to go ahead and answer those and dig deeper into whatever it is you'd like me to dig deeper into. So let's take a look.
Thank you so much, Tanmay. This was so riveting and so encouraging for all of our participants as well. So one question that sort of got lost in the slew of comments when they were listening to your Autolyricist Summertime Song is, what is the difference between AI and ML?
That is a great question. I love that. Artificial intelligence is, I guess there's 2 ways to categorize it, right? There's the classical way, and there's the way that I think we actually do categorize it today without realizing it, right? The classical way of categorizing artificial intelligence is as this technology that simulates abilities within computers that we used to think were limited to humans. So for example, IBM's Deep Blue that played chess, for the first time and beat a human, I guess you would call that artificial intelligence technically, because again, it's taking something that we used to think was limited to humans and doing it within machines. Even though it's not intelligent, doesn't do it through intelligence, it's doing something that we used to think required intelligence, right? That's what I guess you could call artificial intelligence. The way that I think we think of artificial intelligence today is more of or actually less of a technology term and more of a user experience term. Right? So when you're using a piece of technology that looks or feels intelligent, that's when we start to call it artificial intelligence, regardless of the technology behind it. So the Apple Watch, for example, does fall detection. So if I take a fall, it'll tell me, hey, you took a fall. If you don't respond within 60 seconds, I'll call emergency services. And that uses, really advanced machine learning on the watch. And Siri on the phone uses machine learning to talk to me. But we don't call the watch fall detection artificial intelligence because it doesn't feel intelligent, but we do call Siri artificial intelligence. So I feel like AI is more of a user experience term. Machine learning is the term for, sort of an umbrella term for a bunch of different algorithms that help us extract patterns in data, implement tasks like classification and regression in order to help us, once again, take input data that maybe we've never seen before and try and extrapolate it into some other form. So machine learning is the actual technical term. AI is more of the user experience and what the user sees term.
All right. I think a couple of students were very interested in your Heart ID project and said they have several questions. So I'm going to let them take it up with you, perhaps on Discord, and continue to chat with you there, since you are available on the server, right, Tanmay?
Yes.
He probably be able to hang out there for a little bit today. I don't want to take away time from his Saturday. Thank you so much, Tanmay, for being here with us and inspiring every one of us with your knowledge around this space and the really cool projects. I love that summertime song. Every time you play it, it's awesome.
Thank you.
Thank you again
Thank you
so much.
Thank you. Once again, feel free to ask any more questions in Discord.
Yes, absolutely. Thank you.
All right. Yeah.
Okay.
Thank you.
And what I'd like to do is really quick bring up two of our student ambassadors, IBM Z student ambassadors, who are here today to join us, Divya Goswami and Komal Mann, to hi, and welcome them to our fireside chat real quick. I'll make this short and quick and sweet. These are young students, going to let them introduce themselves, who are going sort of, finding ways to differentiate themselves, learning about new technologies, finding that it is interesting, intriguing. So I'm going to let them tell their stories, but first, with a round of introductions, right? So Komal and Divya, if you could come off mute and quickly introduce yourselves. And while you do that, actually tell a little bit about your own coding story, if you will, or your journey to coming to IBM Z. And then we'll talk about what you've learned there, but that would be great. Komal, do you want to go off mute? I see you on the... Can anybody hear me? Komal or Divya?
Can you hear
We can hear you.
Okay. I can't hear Lata. I think Lata's speaking, but I can't hear her.
Okay, I just got unmuted. Actually, we were not able to unmute ourselves. Can you hear me?
Yeah, can hear you, Divya. Yeah.
Yes.
Okay, perfect. So I am Divya Goswami from India. I guess all here are mostly Indians. But yeah, so I'm from Kolkata, from Heritage Institute of Technology, and I am currently in third year. I'm interning I use Linux. Yeah, that's the introduction.
Divya, do you want to go off camera? It's a little hard to hear you. I don't know if everyone else is having that problem.
And she may have to log out and log back in again also to try.
Yeah, or just go off camera to see if that helps with the bandwidth.
Right.
Okay.
Divya, are you there? Okay, Komal, why don't we have you go and talk a little about your journey and Z student ambassador program while Divya tries to figure out some of the tech issues on her end. Yeah. Okay, so Komal is unable to unmute. Can someone unmute her, please?
No, I'm just trying to figure it.
She can speak now.
Yeah, she's the same thing.
Am
as
I audible now?
Hello.
I hear you, Nathan, now.
Hello, am I audible?
Yeah, you are. I hear you. But I think Kamal, we can't hear Kamal.
Maybe video is disabled because I can see myself, but
Hi, can you hear me now?
Yes.
Yeah, sorry
Yeah.
about this issues. Let me introduce myself. Hello, everyone. I am Komal, a final year computer science engineering student from India, Chandigarh University. And I'm very passionate about sharing my skills forward in whatever ways I can. And I'm here today to do the same and share the opportunities that I have been able to grab with IBM Z. And I have been working as an IBM Z ambassador since last year, working with IBMers, collaborating with global group of Z ambassadors over cool IBM Z opportunities and interacting with the team to bring out really useful content for other students from all over the globe. I'm very excited to be here today, and thank you, Sudarshana, for inviting me to speak here today, and cannot wait to share my journey and everything.
Komal? All right. Divya, did you want to try again just to speak?
yeah, hopefully I'm audible right now.
Yes.
Okay, cool. So this is Divya Goswami from Kolkata, India. I'm a third year student. Right now interning with Trell as a DevSecOps intern. And yeah, I got interested into the C Ambassador program some months after I got a chance to be with Open Mainframe Project at a mentorship program. And that's how I came here. And again, thank you, Sudarshan, for inviting me. I'm happy to be here.
All right. Thank you both. And I know, you both said you're an IBM student ambassador. So if you can just talk a little about what it means and how what you do, and how can someone here in the audience be part of that program if they're interested and want to do this, right?
I think Komal can lead this.
So, like I said, I have been into the Z Ambassador program since last year. And if I talk about it, it has been a life-changing journey for me because it really helped me to gain that overall confidence and develop my personality. The reason I'm able to talk to 109 students here today is because of the Z Ambassador program and the opportunities that I got through it that enabled me to have that confidence and the opportunities that I grabbed. I got to know about the Z Ambassador program from one of my seniors in my university, and I'm so grateful that I did. if you want to get into the Ambassador program, the applications for this year's cohort are now closed, and we have just started with the 2021 program. But you can always sign up for the next year's program. And to do that, I'll share with you a proper opportunity to stay connected with all the student opportunities with IBMZ. So we have a global community of all the students, IBM's at Global Student Hub. It's a community for students like you and me, where we can actually interact with IBMers, ask whatever we want and get our doubts answered. Like, how often do we get such opportunities to interact directly with the industry experts and know whatever we want to? So I'll highly recommend joining this student community, where you can actually build your eminence, write blogs, read tech blogs, and know about IBMZ student opportunities. And if I talk about IBMZ student opportunities, there are tons of that. From R of Z game, letting you introduce to the enterprise computing world, to IBM's Explore platform, Z Ambassador program, there are actually a lot of opportunities to grab for you. And if you want to stay connected with all of that, I highly recommend joining the IBM's at Global Student Hub community. Here is the link to the community, ibm.biz/stars-hub. And if I talk about more reasons to join the hub, then it is, I am a very great testimonial of why should you join the Student Hub, because all I have been able to do is because of the Student Hub and the IBMers there and the student and entrepreneur experience team. You can also win t-shirts and other prizes. Exclusive IBM swags are waiting for you on the hub. And if you're active there, if you're constantly engaging with the Z Ambassador, taking part in the flagship student contest, you can learn tech, professional development, and entrepreneurship skills, and also be featured in IBM videos and blogs. As I said, network and connect with experts and IBMers. So I highly recommend joining it. Don't miss the chance to be a part of this global community, where you can actually meet students like me and Divya, where we share our journey, that how IBMZ helped us transform our overall career and learning journey. So I'll quickly share my screen and let Divya talk about her journey.
That's awesome. Thank you, Komal, for that quick.
Sure.
Divya, I know you mentioned Open Mainframe project early on when you were introducing yourself. So if you can just talk to me a little about how did you find out about the Open Mainframe project summer mentorship and what you took away from that experience about being, having the two terms, mainframe, open source, and bringing that all together, and what has that experience taught you? And more importantly, how did you find out about it?
I think Divya's
Yeah, so it looks like
sorry, I couldn't hear you. Can you repeat?
I was asking about your Open Mainframe project experience and how you got to know about it and what that experience was like.
Yeah, I think bandwidth is like pretty bad.
Yeah, so Koma, just come back to you real quick, and maybe we wrap this up because students are waiting to get back to hacking and getting started on the Datathon itself. If you were to give, share one experience or advice with the students here today, what would that be from what you've had as an experience so far?
Komal, are you there?
Yeah, did I lose Koma? I think.
Yeah, we don't see Komal.
Okay. All right. So sorry about all the technology issues. I'm just really glad that, Tanmai's keynote was flawless and we were all able to hear from him. No issues at all there. So thank you, everybody. And good luck with the Datathon. Remember, a couple of things that Tanmai mentioned, and I think captured that in the chat as well. You got to try something new, right? And so remember, IBM Z is one of the many other platforms and technologies that can be used. It has its purpose, right? And it is different, it is new to you, but that does not mean how can you not do it, not use it or avoid it. My recommendation is come, give it a try. This is your opportunity to learn about IBM Z as a different architecture and a platform. And also realize that it actually is not really that different. When you're working on your machine learning project, you will realize that everything that you used to and you're familiar with from maybe your data science class is what you will be doing even with IBM Z on the back end. So keep an open mind, get in there, get your instance, and get started. We're eager to see all of your submissions, and we'll meet again in 1 week when we're ready to announce the winners. But until then, it's hacking time.
Yeah, we have a couple more slides on the actual Datathon. So Akanksha, do you want to take it over on the specifics just before we all move to Discord? Just 2 more slides. Akanksha, are you there?
Hi, am I audible? So can you
There you
please
are.
share the slides?
Yes. Sok, are you sharing the slide deck, please?
Wow, over there. There you go.
Okay. Yeah.
Yeah, so thank you everyone for joining today. And I'm sure like everybody is excited to just started with coding and everything. So we shared the Datathon guidebook. So you can find all the links and everything here. We have mentioned different Discord channels, what's their use, all the raffle prizes. So as you can see, we recently added the best team photo raffle. So we would love to see all your team photos, and yeah, just keep them coming. And you can find all the links and all the recordings, the live keynote and everything will be updating the guide. So yeah, just keep looking for updates on Discord. Next slide. And yeah, we have mentioned the schedule of the Datathon. So currently we are here, we have to fill the attendance sheet, and I hope everyone has filled that. And then we'll move to Discord for any kind of like help. If you need, just feel free to reach out to our IBM mentors and the staff. And just keep looking for announcements on Discords, and we are going to have a lot of fun events as well. We have Kahoot quiz and other stuff, so we'll be announcing that in Discord. So yeah, just keep looking. And the deadline for submission is 7:30 p.m. IST tomorrow. And after that, we're gonna have just a quick wrap-up meeting. So yeah, that was all. Just you will find everything in the Datathon guide. Next slide. Next slide. So yeah, as Jesse in the social network says, who was playing the Mark Zuckerberg role. So as he said, let the hacking begin. And I hope everybody is excited to make something cool. And yeah, we are also excited to see what you all make. So best of luck, have a great time, and just get ready with all your snacks and laptops and Wi-Fi connection. Just check everything. And yeah, we'll see you on Discord and also in the events tomorrow. Good luck, everyone.
Okay. Bye, everybody. See you.
Bye. Awesome.
Bye, all at Discord. Bye.
Good luck, everyone. Chat on Discord. See you there.